You know, when we look up at the night sky, we tend to see this silent, peaceful expanse. We dream about floating among the stars, right? But what if all that peace is just a beautiful illusion? Today, let's explore why the reality of space is way more hostile than you could possibly imagine.
Yeah, this quote really nails the dream, doesn't it? Space is this serene, majestic backdrop. It's a gorgeous idea, this huge, empty canvas. But that's the very idea we're here to challenge.
So what if that canvas isn't empty at all? What if it's actually filled with invisible, violent forces that are actively trying to dismantle everything we send into it, including us? All right, let's break down the true nature of space, and we're going to start with its most immediate victim, the human body.
Okay, so forget about aliens or getting hit by a giant asteroid for a minute. The most immediate, most certain threat in space is just space itself, and its assault on you begins at the molecular level.
And that brings us to this absolutely terrifying concept called ebullism. Now, this isn't like those sci-fi movies where people just explode. It's weirder. In the pure vacuum of space, there's no air pressure, which causes the boiling point of liquids to drop dramatically. That means the water on your tongue, in your eyes, even the thin layer lining your lungs, would instantly boil away.
That's how much time you've got, just 15 seconds. In that short time, the lack of oxygen pressure means you lose consciousness. The vacuum is literally pulling the air right out of your lungs and your blood. It's an incredibly swift and totally unforgiving environment.
And even if you're safe and sound inside a spacecraft, there's a much slower, snakier violence at work. That weightlessness, the stuff that looks so fun, it's a physiological nightmare. Your body, which evolved for Earth's gravity, just starts to fall apart. Your bones lose density, up to 1% a month. Your muscles waste away. Even your heart gets weaker and changes shape. It is a relentless, system-wide decay.
Then you've got the invisible storm, cosmic radiation. This quote, well, it puts things into a truly stark perspective. Once you're outside Earth's protective magnetic bubble, you're just getting blasted by high-energy particles that slice right through your DNA. This is not a small risk. We're talking about a constant, high-dose exposure that has massive long-term health consequences.
So you might be thinking, okay, just build thicker walls, right? Well, it's not that simple. Because of this bizarre effect called spallation, when one of those high-energy particles hits the hull of your ship, it's like a tiny explosion. It shatters the atoms in the metal, creating a spray of secondary radiation inside the spacecraft. In a crazy twist, your own shield becomes a weapon against you.
So we've established the human body is in for a really bad time. But what about all the advanced technology we build to protect it? Well, it turns out space is just as hostile to our machines.
Just look at these insane temperature swings. An object out there can be boiling hot on the side facing the sun, and at the exact same time, deep frozen on the side that's in shadow. This constant extreme cycling from hot to cold causes metal to get tired and crack, electronics to fail, and materials to just fall apart.
And then there's the constant threat of getting shot at by micrometeoroids. This quote gives you a sense of just how powerful they are. You see, space isn't empty, it's a high-speed shooting gallery. Millions of these tiny particles, moving at insane velocities, can puncture a ship's hull, cut a power line, or shatter a window. Every single impact is a potential disaster.
And you know what's really scary? It's not just the natural space rocks. Our own junk up there creates this terrifying possibility called the Kessler syndrome. It's a chain reaction. One collision creates more debris, which then causes more collisions, and on, until low Earth orbit becomes a lethal, impassable minefield. We could literally trap ourselves on our own planet.
And as if all of that wasn't enough, it turns out space is also trying to eat our spacecraft. As you can see here, different materials face different threats. In low Earth orbit, for example, the sun's intense UV radiation creates something called atomic oxygen. These are single, super-reactive atoms that basically act like a sandblaster, eroding away at metals, plastics, and even the fabric of spacesuits. So far, we've talked about threats that are, extreme, but at least understandable. But now, we're going to go to a place where the fundamental laws of physics themselves become the weapons. And no, this is not something out of a comic book. It's a real thing called spaghettification. If you get too close to something super dense, like a black hole, the pull of gravity on your feet could be billions of times stronger than on your head. That difference in force would stretch you or any object into a long, thin stream of atoms.
Its destruction so complete it dismantles matter itself.
And the universe's creativity for destruction doesn't stop with gravity. Take a magnetar. It's a type of neutron star with a magnetic field so unbelievably powerful that the forces are intense enough to break chemical bonds. Molecules can't hold together. The very concept of chemistry dissolves. Life as we know it is just physically impossible. Then, on the grandest scale, you have the truly cosmic catastrophes, events of unimaginable power. Gamma-ray bursts unleash more energy in just a few seconds than our sun will in its entire lifetime, and they can sterilize life across thousands of light years. These aren't just dangers, they're basically cosmic reset buttons.
Okay, so after walking through that cosmic horror show, it really forces you to look back at our own little blue dot here in a completely different light, doesn't it?
So why are we safe? Well, because of this. Earth isn't just a rock with some life on it. It's an incredibly complex, perfectly integrated life support system. We have a magnetic field that shields us from deadly radiation. We have a thick atmosphere that gives us pressure and filters out harmful rays. And we have a stable gravity that's strong enough to hold it all together, but gentle enough not to tear us apart.
And this really is the ultimate takeaway. Understanding just how hostile the rest of the universe is reveals just how precious and maybe how rare our own planet is. It's a sanctuary, an almost impossible island of stability in a cosmic ocean of absolute violence.
So in the end, this isn't just about the dangers out there. It's really about recognizing the incredibly intricate systems that protect us right here. And that leaves us with one final, very big thought. If Earth is our only spaceship in this hostile universe, what's our responsibility to take care of it?